What if the most pivotal event in our ancient past, a true global reset, has been deliberately obscured, hidden in plain sight? We're talking about a time when the sky itself burned, when walls of water engulfed continents, and when an advanced human society might have been utterly wiped from the face of the earth. This isn't just theory. This is the Younger Dryas, and it challenges everything. The year is approximately 12,800 years ago. Imagine standing on a thriving coastal plain. Suddenly, the sky streaks with fire. Fragments rain down. Massive comet pieces, some the size of mountains, pepper the earth. Behind you, colossal ice sheets, millennia old, begin to crumble. They unleash torrents that will reshape entire continents. This isn't a biblical epic or a sci-fi nightmare. This is the Younger Dryas. It might be the most crucial event in human history you've never heard of. Welcome to a journey into forbidden history. We will explore the shadows between what we think we know and what might truly be. I am your guide through these twilight hours. Tonight, we dive deep into a question that could rewrite civilization itself. What if, 12,800 years ago, an advanced human society was erased in a few catastrophic decades? What if the megalithic monuments, the stone circles, the flood myths spanning the globe are not coincidences? What if they are fragments of memory from a world reset to zero? For the next hour, we will chase the evidence. We will uncover traces that suggest our ancestors were far more sophisticated than we've been taught. We will explore geological scars from cosmic impacts. We will examine the mysterious timing of humanity's first monumental architecture. We will consider the possibility that beneath our oceans lie the ruins of cities predating everything we call civilization. This is a story of survival, of memory etched in stone and myth, of knowledge's resilience, even against global catastrophe. Settle in. Let the familiar pull of sleep draw you closer. Join me as we uncover what might be the greatest reset in human history. The sky on fire. The story begins not with a whisper, but with fire falling from the sky. Imagine early humans noticing something profoundly wrong with the heavens. For weeks, perhaps months, strange lights danced across the night sky. Shooting stars became more frequent, brighter, more numerous. Then the sky itself seemed to crack open. What struck our planet 12,800 years ago wasn't a single object. It was likely a colossal comet, perhaps 60 miles in diameter. It shattered into countless fragments as it approached Earth. These pieces, from mountain-sized chunks to smaller but still devastating meteorites, created a cosmic shotgun blast. It peppered multiple continents simultaneously. The proof for this cataclysm lies written in the very soil beneath our feet, in sediment layers containing materials that simply shouldn't exist naturally on Earth's surface. Across North America, Europe, the Middle East, even South Africa, scientists discovered what they call the black mat, a thin layer of darkened earth. It appears like a scar in the geological record. Within these layers lie nanodiamonds, microscopic crystals. They form only under the extreme pressures of cosmic impact. There are metallic spherules, tiny droplets of rock. They melted and flung through the atmosphere. Then they cooled and fell back to Earth. Elevated levels of iridium and platinum, elements rare in Earth's crust, but common in comets and asteroids, spiked dramatically in sediments from this exact period. But perhaps most telling is what happens immediately after these black mat layers appear. Above them, the bones of massive creatures which had roamed Earth for millions of years simply vanish. Mammoths, mastodons, saber-toothed cats, dire wolves, giant ground sloths, dozens of other species. They had survived previous ice ages. Now they disappear from the fossil record. In North America alone, 35 genera of large mammals went extinct. This represents roughly 70% of all large animal species on the continent. The human cost was likely just as devastating. The sophisticated Clovis culture, known for beautifully crafted stone tools and successful big game hunting, abruptly disappears from the archaeological record. Precisely at this same moment, their distinctive spear points, found across much of North America, are never seen again after the black mat layer. It's as if an entire way of life was erased in a geological instant. Now imagine you are a survivor of this cosmic catastrophe. You witnessed the sky burn with falling fire. You felt the ground shake as massive impacts cratered the landscape. You watched as the great herds, your people followed for generations, fled into smoke and chaos. They never returned, but the immediate destruction was only the beginning. The long winter. The debris thrown into the atmosphere blocked out sunlight for months, perhaps years. Temperatures plummeted. This cosmic winter took hold. Some regions experienced drops of up to 18 degrees Fahrenheit, but this wasn't just temporary cooling. The impacts had triggered something far more sinister, a complete shutdown of the ocean currents that regulate Earth's climate. The massive Laurentide ice sheet, covering much of northern North America, began to collapse. The impacts and resulting fires weakened its structure. Glacial Lake Agassiz, a body of fresh water larger than all the modern Great Lakes combined, burst through its ice dams. It poured into the North Atlantic. This enormous pulse of fresh water disrupted the Atlantic meridional overturning circulation, the Great Oceanic Conveyor Belt. It carries warm water northward and cold water south. Without this circulation system, the relatively mild conditions that had been emerging as the last ice age ended were suddenly reversed. The planet plunged back into full glacial conditions. Geologists call this the Younger Dryas period. For 1,200 years, ice advanced again across northern Europe and North America. Sea levels dropped. Water locked up in expanding glaciers. Forests died. Tundra replaced them. The brief warming trend, which had promised a gentler world, was brutally cut short. But here's where our story takes a fascinating turn. What if the world destroyed wasn't populated only by small bands of hunter-gatherers? What if there were already complex societies, early cities, sophisticated knowledge systems? What if they were all wiped away by this cosmic reset? Consider the timing. The Younger Dryas impact occurred 12,800 years ago. The world remained locked in this artificial ice age for over a millennium. Then, almost immediately after the climate stabilized again, around 11,600 years ago, something remarkable happened. Gobleki Tepe, the first temple. Göbekli Tepe, a massive stone temple complex in modern-day Turkey, began construction. This isn't a simple arrangement of standing stones. It's a sophisticated architectural achievement, precisely carved limestone pillars, weighing up to 20 tons each, arranged in perfect circles, decorated with intricate reliefs of animals and abstract symbols. The conventional archaeological narrative tells us Göbekli Tepe was built by hunter-gatherers. They supposedly organized themselves into a workforce. They quarried, transported, and erected these massive stones, all without domesticated animals, without metal tools, without even pottery. They accomplished this feat before they learned to farm, before permanent settlements, before writing, before any other technologies we associate with complex civilization. But what if Göbekli Tepe wasn't the beginning of monumental architecture? What if it was its rebirth? What if the knowledge and organizational systems needed to create such structures had survived the Younger Dryas catastrophe, preserved by small groups of survivors? They waited over 1,000 years for conditions to stabilize. Then they began building again. This possibility becomes even more intriguing when we examine some of Göbekli Tepe's carvings. The famous vulture stone, one of the most elaborate reliefs, depicts what some researchers believe is a record of the cosmic catastrophe, the one that triggered the Younger Dryas. The stone shows various animals, which may represent constellations, along with what appears to be a comet or meteor. Using computer software to match these carvings to actual star positions, researchers calculated that the scene depicted corresponds to the night sky around 10,950 BCE. This is very close to the proposed date of the Younger Dryas impact. Could this stone be an ancient record, a deliberate attempt by survivors to preserve the memory of the catastrophe that destroyed their world? If so, it would suggest the builders of Göbekli Tepe possessed not only technical skills for monumental architecture, but also sophisticated astronomical knowledge, and a complex system for recording and transmitting information across generations. The mystery deepens when we consider that Göbekli Tepe was deliberately buried around 8,000 years ago. The site wasn't abandoned to decay naturally. Instead, it was carefully covered with tons of earth and rubble, as if its creators wanted to preserve it for future discovery. Why would a society invest enormous effort in creating such a magnificent complex only to bury it intentionally? Perhaps they knew their knowledge was fragile, that catastrophes could strike again. That stone buried deep in the earth was the only way to ensure their message would survive. Göbekli Tepe isn't alone in this pattern. Across the globe, we find other examples of sophisticated megalithic construction. It begins almost immediately after the Younger Dryas ended. In Peru, the massive stone blocks of Sacsayhuaman fit together with such precision that a knife blade cannot slip between them. On Easter Island, nearly 900 massive statues stare inland from their coastal positions. Their construction required advanced knowledge of engineering and logistics. In Lebanon, the Baalbek complex features foundation stones weighing over 800 tons each, moved and positioned with a precision that challenges our understanding of ancient capabilities. Each of these sites presents the same puzzle. How did societies, which we are told were just emerging from primitive conditions, suddenly display such advanced architectural and engineering knowledge? The conventional explanation requires us to believe in multiple independent inventions of sophisticated construction techniques, each arising spontaneously in different parts of the world, all within a few thousand years of the Younger Dryas ending. But there's another explanation, one that the growing body of evidence seems to support. What if these weren't independent inventions at all? What if they were the re-emergence of knowledge that existed before the cosmic reset? What if scattered survivors of a more advanced pre-Younger Dryas civilization preserved fragments of their architectural, astronomical, and engineering knowledge through the dark centuries of the artificial Ice Age, waiting for conditions to improve enough to begin building again? Drowned cities, echoing myths. This possibility is supported by more than just the mysterious timing of megalithic construction. Recent advances in underwater archaeology and satellite imaging revealed structures on continental shelves around the world. They appear artificial, but are submerged under hundreds of feet of water. Off the coast of India, in the Gulf of Cambay, sonar detected what appear to be geometric patterns and structures buried under marine sediments. Near the Bahamas, underwater formations known as the Bimini Road show linear arrangements of stone blocks. Some researchers argue these are too regular to be natural. These underwater anomalies become particularly significant when we remember that sea levels at the end of the last ice age were nearly 400 feet lower than today. Vast areas of what is now ocean floor were dry land during the period leading up to the Younger Dryas impact. The Doggerland Plain connected Britain to continental Europe. The Sunda Shelf linked Southeast Asia into a single landmass. Coastal plains stretched far beyond their current boundaries on every continent. If advanced civilizations developed during the millennia before the Younger Dryas, they would most likely have been located in these fertile coastal areas, with access to marine resources and river deltas. When the impact triggered climate changes, caused massive ice sheets to collapse and sea levels to rise rapidly, these coastal civilizations would have been the first casualties. Their cities, their ports, their agricultural areas, their populations, all submerged beneath hundreds of feet of rising ocean. This scenario would explain one of the most persistent mysteries in human cultural development. Why do flood myths appear in virtually every human society on Earth? From the biblical account of Noah to the Mesopotamian epic of Gilgamesh, from Hindu traditions of Manu to Native American stories of world-cleansing deluges, cultures with no contact, all preserved stories of a great flood, one that destroyed an earlier world. Anthropologists traditionally explain these similarities as archetypal myths. They arise naturally from human psychology, metaphors for spiritual rebirth and renewal. But what if there's something else entirely? What if they're cultural memories of actual events, passed down through thousands of generations by the descendants of survivors? Those who witnessed their coastal homelands disappear beneath rising seas. The power of oral tradition to preserve historical information across vast time periods has been dramatically underestimated by modern scholars. Aboriginal Australians maintained accurate oral histories of geological events that occurred more than 30,000 years ago. These stories describe specific landscapes, volcanic eruptions, and sea level changes, all confirmed by modern scientific research. If oral tradition can preserve accurate information about events from 30,000 years ago, it can certainly preserve memories from 12,800 years ago. The Stone Library. But the survivors of the Younger Dryas catastrophe didn't rely solely on oral tradition. They encoded knowledge in stone, in mathematical relationships, in astronomical alignments, things that would outlast any spoken word. The great stone circles, the megalithic temples, the precisely oriented pyramids and monuments. They appear around the world in the millennia, following the Younger Dryas, fragments of a vast knowledge preservation system, an ancient library written in stone and geometry. Consider the implications of this stone library. When we examine sites like Stonehenge, Newgrange, or the stone circles scattered across Britain and Ireland, we find structures aligned with extraordinary precision to celestial events. The massive trilithons at Stonehenge frame the sunrise on the summer solstice with mathematical accuracy. The Passage Tomb at Newgrange in Ireland channels the light of the winter solstice dawn into its inner chamber. It illuminates ancient spiral carvings that seem to dance in the brief golden light. These aren't random orientations. They represent sophisticated understanding of astronomy, geometry, and engineering. They require generations of careful observation and mathematical calculation. But here's what makes this even more remarkable. The knowledge embedded in these structures often exceeds what would have been necessary for the simple agricultural societies we believe built them. Why would Neolithic farmers need to track the precession of the equinoxes, a cycle that takes 26,000 years to complete? Why encode complex mathematical constants like pi and phi into their stone monuments? Why align structures not just with obvious celestial events like solstices, but with subtle astronomical phenomena? These require sophisticated understanding of celestial mechanics. The answer might be that they weren't creating this knowledge from scratch. They were rebuilding it, restoring astronomical and mathematical systems that developed long before the cosmic catastrophe reset their world. This preservation of advanced knowledge becomes even more intriguing when we examine the mysterious emergence of agriculture itself. The conventional narrative tells us humans discovered farming independently in multiple locations, all within a few thousand years of each other. Shortly after the Younger Dryas ended, in the Fertile Crescent, people suddenly began cultivating wheat and barley. In China, they started growing rice. In Mesoamerica, they developed maize. In the Andes, they domesticated potatoes and quinoa. This simultaneous agricultural revolution across disconnected continents has always puzzled researchers. How did hunter-gatherer societies all hit upon the same revolutionary idea within such a narrow time window? The standard explanation involves climate change. It created conditions favoring plant cultivation. But this doesn't fully account for the sophisticated understanding of selective breeding, crop rotation, and agricultural planning that early farming required. What if agriculture wasn't invented after the Younger Dryas, but reinvented ? What if survivors of the catastrophe possessed knowledge of plant cultivation? It developed over thousands of years before the cosmic impact. During the long centuries of the artificial ice age, this knowledge would have been largely unusable. But as soon as climatic conditions stabilized, survivors could have begun teaching agricultural techniques to the hunter-gatherer populations they encountered, seeding the rapid agricultural revolution that followed. This scenario gains support when we examine the genetic history of our most important crop plants. Many show signs of being selectively bred from wild ancestors, in ways that required sophisticated understanding of plant genetics and breeding techniques. The transformation of wild teosinte into modern corn, for example, involved genetic changes so complex that some researchers argued they couldn't have occurred through simple trial and error by primitive farmers. Underwater whispers. But the evidence for pre-Younger Dryas civilization isn't limited to agriculture and megalithic construction. In recent decades, underwater archaeologists explored submerged continental shelves with increasingly sophisticated technology. And what they're finding challenges our understanding of early human development. Off the coast of Gujarat in western India, marine archaeologists discovered what appeared to be the remains of a large urban settlement, submerged in 120 feet of water. Structures, revealed through side-scan sonar and sub-bottom profiling, show regular geometric patterns, consistent with planned urban development. Pottery shards and other artifacts recovered from the site have been radiocarbon dated to over 9,000 years old. This makes it potentially one of the oldest urban settlements ever discovered. Similar underwater anomalies have been found off the coasts of Japan, Cuba, and the eastern Mediterranean. Near Yonaguni Island in Japan, divers explored what appears to be a massive stepped pyramid complex, carved from solid bedrock. Submerged beneath 75 feet of water, the structure features right-angle cuts, geometric shapes, and what appear to be stairs and terraces. These are difficult to explain as natural formations. In the waters of Cuba, sonar mapping revealed geometric stone structures at depths of 2,100 feet, far deeper than any known ancient human settlement. The structures appear to include pyramids, circular buildings, and what looks like a large urban complex. It covers several square miles of ocean floor. The depth at which these structures lie suggests they would have been submerged for at least 12,000 years. This places them firmly in the pre-Younger Dryas period. These underwater discoveries face intense skepticism from mainstream archaeology, for understandable reasons. Accepting their artificial origin would require a fundamental revision of our timeline of human development. But as underwater exploration technology improves, more of these anomalous structures are discovered. It becomes increasingly difficult to dismiss them all as natural formations or misinterpretations. A paradigm shift. The resistance to these discoveries reveals something important about how scientific paradigms change. Thomas Kuhn, in his groundbreaking work on scientific revolutions, noted that new paradigms aren't accepted gradually. Instead, they face fierce resistance, until the weight of contradictory evidence becomes so overwhelming that the old paradigm suddenly collapses. It is then replaced by the new one. We may be approaching such a paradigm shift in our understanding of early human civilization. The evidence for advanced pre-Younger Dryas societies continues to accumulate from multiple independent sources. Genetic analysis reveals ghost populations in human DNA, ancient lineages that contributed to modern populations, but have no clear archaeological correlates. These genetic ghosts suggest complex population movements and mixtures occurred in prehistory. They aren't accounted for in our current models of human development. Advanced dating techniques applied to megalithic sites consistently push their origins back earlier than expected. Göbekli Tepe itself has been redated multiple times. The oldest structures are now believed to be over 12,000 years old. Similar revisions occurred at sites worldwide. New dating methods reveal greater antiquity than previously suspected. Perhaps most intriguingly, computer modeling of ancient astronomical alignments reveals that many megalithic sites encode sophisticated knowledge of celestial cycles, knowledge that wouldn't have been directly observable by their supposed builders. The Nebra sky disk, discovered in Germany and dated to about 3,600 years ago, depicts astronomical knowledge. It required centuries of careful observation to develop. Yet, it appears in the archaeological record without any clear developmental sequence. It doesn't show how this knowledge was acquired. This pattern repeats across cultures and continents. Advanced astronomical, mathematical, and engineering knowledge appears suddenly, fully formed, without clear antecedents. It's as if someone flipped a switch, turning on sophisticated knowledge systems that had been dormant for over a millennium. The switch, of course, was the end of the Younger Dryas artificial ice age. As temperatures warmed and ice sheets retreated, as sea levels stabilized and ecosystems recovered, the conditions became right for civilization to emerge from its long hibernation. The survivors who preserved fragments of pre-catastrophe knowledge could finally begin the work of reconstruction. But they weren't starting from a blank slate. They carried with them the memories, the techniques, and the wisdom of the world that had been lost. This explains why the earliest post-Younger Dryas civilizations display such remarkable sophistication. They weren't primitive societies slowly developing new technologies. They were inheritors of a broken tradition, working to rebuild what had been destroyed. This inheritance wasn't limited to practical knowledge. It included spiritual and philosophical systems, systems that developed over millennia before the cosmic reset, the mystery schools of ancient Egypt, the shamanic traditions of the Americas, the philosophical insights of early Indian civilization. All may trace their roots back to pre-catastrophe wisdom traditions. They were preserved through the dark centuries, finally able to flourish again as the world healed. The great temples and monuments that arose in the millennia following the Younger Dryas weren't just impressive architectural achievements, they were statements of defiance against the forces that nearly erased human civilization. They declared that knowledge could survive catastrophe, that human wisdom could outlast cosmic destruction, that the achievements of the past would not be forgotten. In the precision of their construction, the sophistication of their astronomical alignments, and the mathematical constants encoded in their proportions, these monuments carried forward the intellectual achievements of the lost world. They served as both libraries and schools, preserving ancient knowledge while teaching it to new generations who grew up in the post-catastrophe world. As we drift deeper into this ancient mystery, consider the implications of what we've explored. If human civilization is indeed far older and more sophisticated than we've been taught, then our species faced and survived a cosmic catastrophe of unimaginable proportions. We are the descendants not just of hunter-gatherers who discovered agriculture, but of survivors. They rebuilt their world from fragments and memories, after watching everything they knew disappear beneath fire, ice, and rising seas. This story of survival and reconstruction continues to unfold. New evidence emerges from beneath the waves, within genetic codes, in the astronomical alignments of ancient monuments. The next chapter of our journey takes us deeper into the specific mechanisms of destruction and preservation, exploring how knowledge can survive when civilizations cannot, and how the careful study of myth and monument continues to reveal the hidden history of our species. This story of resilience becomes even more compelling when we examine the curious distribution of certain technologies and symbols across the ancient world. The resurfacing of knowledge. In the millennia following the Younger Dryas, we find remarkably similar construction techniques appearing simultaneously, in locations separated by vast oceans and continents. The precision-cut stone blocks of Pumapunku in Bolivia mirror those found at Sacsayhuaman in Peru, yet both echo the megalithic construction methods seen at sites like Baalbek in Lebanon and the Cyclopean walls of ancient Greece. These aren't simple similarities that might arise from parallel development. They represent specific technical solutions to complex engineering problems. The H-shaped clamps used to join massive stone blocks in ancient Peru appear in identical form at sites in Egypt and Easter Island. The technique of cutting and fitting enormous stones with such precision that no mortar is needed shows up independently across multiple continents, all within centuries of each other. How do we explain this phenomenon? The conventional archaeological model requires us to believe that dozens of separate cultures independently developed identical solutions to problems they shouldn't have even encountered in their supposed developmental stages. It's like finding the same complex mathematical equation solved identically by students who never attended the same school, never shared textbooks, and lived in completely different centuries. But if these techniques were part of a knowledge system that predated the Younger Dryas catastrophe, then their simultaneous reappearance makes perfect sense. Survivors carrying fragments of ancient engineering knowledge would have eventually encountered suitable stone deposits and stable enough social conditions to begin construction projects. The techniques would have emerged not as inventions, but as recovered memories, applied to new circumstances. This pattern extends beyond construction methods to include symbolic systems. These appear across ancient cultures with startling consistency. The spiral, perhaps the most ubiquitous symbol in prehistoric art, appears carved in stone from Ireland to New Mexico, from Australia to Siberia. These aren't simple decorative motifs. Complex spiral patterns encode mathematical relationships, astronomical cycles, and what appear to be sophisticated mapping systems. At Newgrange in Ireland, the famous triple spiral carved at the entrance to the passage tomb incorporates precise mathematical ratios that relate to the monument's astronomical alignments. Similar mathematical spirals appear in the rock art of the American Southwest, where they seem to track solar and lunar cycles with remarkable accuracy. In Australia, Aboriginal Dreamtime symbols include spiral patterns. These encode complex navigational information, allowing travelers to find water sources and safe passage across vast distances. These symbolic systems suggest something far more significant than decorative art created by primitive societies. They point to a shared mathematical and astronomical language, one that transcended cultural boundaries. This language appears suddenly in the archaeological record, fully formed and sophisticated, without clear developmental antecedents in any of the cultures that used it. Consider the implications. If scattered survivors of a pre-Younger Dryas civilization carried with them not just practical knowledge, but also symbolic and mathematical systems, then the reappearance of similar symbols across disconnected cultures represents the reconstruction of a lost universal language. The monuments themselves become libraries. They're carved symbols preserving information that could survive, even if the people who created them did not. This possibility gains support from recent advances in archaeoastronomy, the study of how ancient monuments relate to celestial phenomena. Researchers discovered that many megalithic sites encode information about astronomical cycles that extend far beyond what would have been needed for simple agricultural calendars. Some monuments track the precession of the equinoxes, a 26,000-year cycle. It was supposedly unknown to ancient peoples. Others align with stellar positions that would have been accurate not for the time of their construction, but for periods thousands of years earlier. The Sphinx's gaze. The Great Sphinx of Giza provides a fascinating example of this temporal displacement. While mainstream archaeology dates the monument to around 2500 BCE, its precise astronomical alignment corresponds to a much earlier period. The Sphinx gazes directly east. Computer models of ancient star positions reveal it would have looked straight at the constellation Leo during the spring equinox around 10,500 BCE. This date falls precisely within the period immediately following the end of the Younger Dryas. Similar temporal displacements appear at megalithic sites around the world. The alignment of the Giza pyramid complex with the constellation Orion corresponds most precisely to star positions from around 10,500 BCE, not to the supposed construction date thousands of years later. The stone circles of Nabta Playa in the Egyptian desert align with stellar configurations from approximately 11,000 years ago. Yet, the conventional dating of the site places its construction much later. These astronomical alignments suggest the builders of these monuments possessed detailed knowledge of stellar positions from a much earlier era. How could Bronze Age or Neolithic societies have known the precise positions of stars from thousands of years before their time? The most logical explanation is they inherited this knowledge from earlier observations, preserved through the dark centuries of the Younger Dryas, and finally encoded in stone when conditions allowed for monument construction to resume. The preservation of such precise astronomical knowledge points to sophisticated methods of information storage and transmission, methods we're only beginning to understand. Recent research into the information content of megalithic monuments reveals they function as complex data storage systems, encoding multiple layers of information in their proportions, alignments, and geometric relationships. The Great Pyramid of Giza, for example, incorporates the mathematical constant pi in its proportions. It encodes the precise dimensions of Earth in its measurements, and aligns with magnetic north to within 360th of a degree. These aren't coincidences or approximations. They represent intentional encoding of sophisticated mathematical and geographical knowledge into a structure designed to survive for millennia. Similar information encoding appears in megalithic sites around the world. Stonehenge incorporates complex geometric relationships. These encode astronomical cycles, mathematical constants, and what appear to be units of measurement based on precise knowledge of Earth's dimensions. The stone circles of the British Isles collectively form geometric patterns. Some researchers argue these represent a vast territorial survey system, encoding geographical information across hundreds of miles of landscape. This suggests the post-Younger Dryas monument builders weren't just creating impressive structures, they were rebuilding a global information network, a stone internet. one that could preserve and transmit complex knowledge across vast distances and time periods. Each monument served as both a node in this network and a storage device, holding specific pieces of a much larger knowledge system. The global network. The network metaphor becomes even more intriguing when we examine the positioning of megalithic sites relative to each other. Many appear connected by geometric relationships that span continents. The Great Circle distance between Giza and Stonehenge, for example, equals exactly 1/60th of Earth's circumference. The distance from Stonehenge to the stone circles of the Orkney Islands incorporates precise geometric ratios. They appear intentional rather than coincidental. These geometric relationships suggest the builders of megalithic monuments possessed accurate knowledge of Earth's dimensions. They used this knowledge to position their structures according to a global plan. This level of geographical knowledge shouldn't have existed in Neolithic or Bronze Age societies. Yet, the evidence of its application appears carved in stone across multiple continents. The implications extend beyond individual monuments to encompass entire landscapes. In Britain, researchers identified what they call the ancient survey systems, a network of geometric relationships connecting stone circles, standing stones, and other megalithic sites, across hundreds of miles. The system appears based on precise units of measurement and sophisticated understanding of geometry and surveying techniques. Similar landscape-scale geometric relationships have been identified in other parts of the world. The positioning of ancient sites in Egypt follows geometric patterns. These extend from the Mediterranean coast to the southern borders of the ancient kingdom. In Peru, the Nazca lines create geometric patterns visible only from the air. This suggests their creators possessed either flight capabilities or extremely sophisticated surveying techniques. The emergence of such complex landscape geometry in multiple locations points to a shared system of geographical knowledge, one that transcended individual cultures. This system appears suddenly in the archaeological record, fully developed, sophisticated, without clear evolutionary antecedents. If this geographical knowledge system predated the Younger Dryas catastrophe, then its reappearance in the post-catastrophe world represents one of the most remarkable achievements in human history. Survivors carrying fragments of ancient surveying and astronomical knowledge would have needed to rebuild not just individual monuments, but an entire global network of precisely positioned reference points. The scale of such an undertaking suggests levels of coordination and communication between distant cultures, levels that challenge our understanding of ancient societies. How did builders in Britain coordinate with those in Egypt to ensure their monuments maintain precise geometric relationships across thousands of miles? How did cultures that supposedly had no contact implement identical measurement systems and construction techniques? The answer may lie in the nature of the knowledge preservation system itself. If the pre-Younger Dryas civilization developed sophisticated methods for encoding and transmitting information, then scattered survivors across the globe could have maintained contact through shared symbolic and mathematical languages. The monuments themselves could have served as communication devices, their precise alignments and proportions conveying complex information to those who knew how to read them. Shared stories, shared trauma. This communication network might explain one of the most persistent mysteries in ancient studies: the sudden appearance of similar religious and mythological concepts in cultures that had no apparent contact. The flood myths we discussed earlier are just one example of shared narratives. They appear across disconnected civilizations. Creation stories, hero myths, spiritual concepts, all show remarkable similarities, even between cultures separated by oceans and millennia. These shared mythological patterns have traditionally been explained as archetypal stories. They arise naturally from human psychology, metaphors for spiritual rebirth and renewal. But what if they represent something more concrete? What if they're cultural memories of actual events, passed down through thousands of generations by the descendants of survivors? Those who witnessed their coastal homelands disappear beneath rising seas. The power of oral tradition to preserve historical information across vast time periods has been dramatically underestimated by modern scholars. Aboriginal Australians maintained accurate oral histories of geological events that occurred more than 30,000 years ago. These stories describe specific landscapes, volcanic eruptions, and sea level changes, all confirmed by modern scientific research. If oral tradition can preserve accurate information about events from 30,000 years ago, it can certainly preserve memories from 12,800 years ago. The encoding of technical and historical information in mythological narratives represents one of humanity's most sophisticated survival strategies. Unlike written records, which can be destroyed by fire, flood, or conquest, oral traditions can survive, as long as there are people to remember and retell them. By embedding crucial information in memorable stories, ancient cultures ensured that essential knowledge would persist, even through periods of social collapse and environmental catastrophe. This preservation system becomes even more remarkable when we consider the precision with which information was maintained across generations. Studies of traditional storytelling cultures reveal that oral narratives can remain virtually unchanged for thousands of years. When they're considered sacred or historically important, the mechanisms of social reinforcement, ritual repetition, and cultural authority that maintain oral tradition accuracy are far more robust than most modern scholars had assumed. The implication is that the mythologies of ancient cultures may preserve accurate historical information from periods far earlier than previously thought possible. If survivors of pre-Younger Dryas civilizations encoded their experiences and knowledge in oral narratives, then these stories could have preserved detailed accounts of the cosmic catastrophe and its aftermath for over 12,000 years. This possibility reframes our entire approach to studying ancient cultures. Instead of dismissing myths as primitive fiction, we should be analyzing them as potential historical documents, looking for encoded information about past events, lost technologies, forgotten knowledge systems. The stories our ancestors told around fires might contain more truth than the textbooks we study in universities. The convergence of evidence from multiple sources, astronomical alignments, genetic analysis, underwater archaeology, and mythological studies creates a compelling case for radically revising our timeline of human civilization. The picture that emerges suggests our species achieved far greater sophistication, far earlier than we've been taught, only to have that achievement nearly erased by cosmic catastrophe. The survivors of this erasure faced a challenge that tests the very limits of human resilience. They had to preserve fragments of advanced knowledge. Through over a millennium of harsh climatic conditions, social disruption, cultural collapse, they had to maintain hope that conditions would eventually improve enough to allow reconstruction. And they had to develop systems for passing their knowledge to future generations, generations who grew up in a world very different from the one that had been lost. That they succeeded in this monumental task is evidenced by the sudden flowering of sophisticated civilizations. In the millennia following the end of the Younger Dryas, the emergence of complex societies in Mesopotamia, Egypt, the Indus Valley, and Peru wasn't the beginning of civilization. It was its renaissance, the rebirth of human achievement after the longest dark. As we continue our journey through this hidden age in recorded history, we'll explore how these Renaissance civilizations encoded their recovered knowledge, how they built upon the fragments preserved by survivors, and how traces of the lost world continue to surface in archaeological discoveries around the globe. The story of the Younger Dryas reset is far from over. In fact, as new evidence emerges and new technologies allow us to peer deeper into the past, we're only beginning to understand the true scope of what was lost and what was miraculously preserved. The seed of civilization. The story becomes even more extraordinary when we examine what happened in the immediate aftermath of the Great Warming. As the Younger Dryas Ice Age finally released its grip, around 11,600 years ago, something unprecedented occurred in human development. Within mere centuries of climatic stabilization, we see the sudden appearance of sophisticated agricultural systems, monumental architecture, and complex social organizations across multiple continents simultaneously. This timing isn't coincidental. It's as if humanity had been waiting, holding its breath through the long, cold centuries, ready to exhale a renaissance of knowledge and achievement the moment conditions allowed. But the speed and sophistication of this emergence challenges everything we think we know about how civilizations develop. Traditional archaeological models suggest complex societies evolve gradually, over many thousands of years. Hunter-gatherers slowly develop agriculture, which leads to permanent settlements, which eventually grow into cities, which finally produce the surplus and organization necessary for monumental construction projects. This process should take millennia, not centuries. Yet what we observe in the archaeological record following the Younger Dryas is the opposite pattern. Complex achievements appear suddenly, fully formed, as if someone had simply flipped a switch. The great temple complexes of Gobleki Tepe begin construction almost immediately after the ice retreats. Sophisticated agricultural systems emerge simultaneously. In the Fertile Crescent, China, Mesoamerica, and the Andes, megalithic construction projects commence across Europe, Africa, and the Americas, all within a remarkably narrow time window. This pattern suggests the knowledge necessary for these achievements already existed, waiting for the right conditions to be implemented. The survivors, who preserved fragments of pre-catastrophe civilization, weren't starting from zero. They were working from blueprints, both literal and metaphorical. Blueprints that had been carefully maintained through the dark centuries. Consider the complexity of what emerged so quickly. The agricultural systems that appeared after the Younger Dryas weren't simple experiments in plant cultivation. They involved sophisticated understanding of selective breeding, crop rotation, irrigation engineering, and food storage techniques. The transformation of wild grasses into productive cereals required genetic modifications so complex that some modern botanists argue they couldn't have occurred through random experimentation by primitive farmers. Take wheat, for example. The journey from wild einkorn grass to the bred wheat that fed early civilizations involved multiple genetic modifications. They had to occur in specific sequences. Wild wheat shatters when ripe, scattering its seeds naturally, making harvesting nearly impossible. Cultivated wheat retains its seeds until harvested, but this trait would be fatal in wild conditions. The development of non-shattering wheat varieties required deliberate selection over many generations, along with the knowledge to recognize and preserve beneficial mutations. Similarly, the transformation of teosinte into modern corn involved genetic changes so dramatic that the two plants appeared to be entirely different species. The process required sophisticated understanding of plant genetics, selective breeding techniques, and long-term agricultural planning. Yet, this transformation supposedly occurred independently in Mesoamerica, within centuries of similar agricultural developments in other parts of the world. The simultaneous emergence of complex agriculture across disconnected continents becomes even more mysterious when we examine the specific techniques involved. Terrace farming appears in the Andes, China, and the Mediterranean. At roughly the same time, advanced irrigation systems emerge in Mesopotamia, the Indus Valley, and Peru. Within centuries of each other, sophisticated food storage and processing techniques develop independently across multiple cultures. These aren't simple innovations that might arise naturally from trial and error. They represent complex technological systems. They require deep understanding of hydrology, soil chemistry, plant biology, and engineering principles. The knowledge base necessary to develop such systems should have taken thousands of years to accumulate, through gradual experimentation and refinement. But what if it hadn't been accumulated gradually? What if this agricultural knowledge represented the recovery of systems that had been developed over millennia before the Younger Dryas catastrophe? Survivors carrying this knowledge would have been unable to implement it during the harsh conditions of the artificial ice age. But as soon as climate conditions stabilized, they could have begun teaching these techniques to hunter-gatherer populations, seeding the rapid agricultural revolution that transformed human society. This scenario explains not only the speed of agricultural development, but also its sophistication. The early farmers weren't experimenting with primitive techniques. They were implementing advanced systems that had been refined over thousands of years of pre-catastrophe development. The agricultural revolution wasn't an invention, but a restoration, the recovery of knowledge that had been temporarily lost to catastrophic climate change. The echo of precision. The same pattern appears in the realm of monumental architecture. The sophisticated construction techniques that appear suddenly in the post-Younger Dryas world aren't the crude first attempts of societies learning to build with stone. They represent advanced engineering knowledge, applied to new circumstances, by people who understood principles of leverage, transportation, precision cutting, and structural stability. The megalithic sites that emerged during this period display consistent features. They suggest a shared knowledge base. Massive stone blocks are cut and fitted with mathematical precision. Structures are aligned with astronomical phenomena. Using sophisticated understanding of celestial mechanics, construction techniques appear that wouldn't be rediscovered by mainstream archaeology until the modern era. At Pumapunku in Bolivia, stone blocks weighing over 130 tons are cut with such precision that they fit together like pieces of a three-dimensional jigsaw puzzle. The cutting techniques involved required tools and methods that supposedly didn't exist in pre-Columbian America. The blocks contain complex interlocking shapes that would challenge modern stone cutters, even those equipped with diamond-tipped tools and computer-controlled machinery. Similar precision appears at megalithic sites around the world. The trilithon stones at Baalbek in Lebanon are fitted together so precisely that their joints remain invisible after thousands of years of weathering and seismic activity. The Cyclopean walls of ancient Peru incorporate stones of such varied shapes and sizes that each block appears to have been custom cut to fit its specific position in the wall structure. This level of precision suggests the builders possessed not only advanced tools, but also sophisticated planning and measurement systems. They needed to know exactly how each stone would fit before beginning the cutting process. They required accurate surveying techniques to ensure massive blocks transported over long distances would align perfectly with structures already in place. The knowledge systems necessary for such achievements don't develop overnight. They require generations of accumulated experience, refined techniques, institutional memory. Yet they appear suddenly in the archaeological record, fully formed and sophisticated across multiple continents, all within centuries of the Younger Dryas ending. The mystery deepens when we examine the astronomical alignments incorporated into these megalithic structures. The builders didn't just possess advanced construction techniques, they also demonstrated sophisticated understanding of celestial mechanics, mathematical relationships, and complex geometric principles. Many post-Younger Dryas monuments encode astronomical information. It extends far beyond simple seasonal calendars. They track complex celestial cycles, incorporate mathematical constants, and align with stellar phenomena. These require centuries of careful observation to understand fully. The knowledge embedded in these structures suggests their builders inherited astronomical systems that developed over thousands of years of pre-catastrophe observation and calculation. The Antikythera mechanism, discovered in an ancient Greek shipwreck, provides a fascinating example of the sophistication that could emerge from recovered knowledge systems. This bronze device, dating to around 100 BCE, functions as a complex analog computer, capable of predicting eclipses, tracking planetary positions, and calculating the timing of Olympic Games decades in advance. The mechanism incorporates gear ratios of extraordinary precision, mathematical relationships that weren't supposedly rediscovered until the Renaissance, and astronomical knowledge that required centuries of careful observation to develop. Yet it appears suddenly in the archaeological record, without clear developmental antecedents, as if someone had simply remembered how to build such devices after a long period of forgetting. Similar examples of advanced knowledge appearing without clear origins can be found across ancient civilizations. The mathematical and astronomical texts of ancient India contain sophisticated calculations, geometric principles, astronomical observations. These suggest access to knowledge systems far more advanced than traditional timelines would suggest possible. The Asurya Siddhanta, an ancient Sanskrit text on astronomy, contains calculations of planetary orbits, stellar positions, cosmic cycles. All remain accurate by modern standards. The text includes mathematical concepts like trigonometry and calculus. They weren't supposedly developed until much later periods. It describes Earth as a sphere rotating on its axis, concepts that mainstream history claims weren't understood until relatively recent times. Egyptian mathematical pottery reveals similar sophistication in geometric principles, algebraic calculations, engineering applications. The builders of the pyramids clearly possessed advanced mathematical knowledge, incorporating precise geometric relationships, mathematical constants, complex proportional systems into their monuments. But where did this knowledge come from? The conventional archaeological narrative requires us to believe these sophisticated mathematical and astronomical systems were developed independently by multiple cultures, within relatively short time periods. It's as if several different groups of people had simultaneously invented calculus, discovered the same geometric principles, and developed identical astronomical models, without any communication between them. The alternative explanation suggests these knowledge systems weren't inventions, but recoveries. Survivors of pre-Younger Dryas civilizations preserved fragments of advanced mathematical, astronomical, and engineering knowledge through the catastrophic period. As conditions stabilized, this knowledge began to resurface in the civilizations that emerged from the survivors' teachings and influence. This possibility gained support from the genetic evidence of human population movements. During the post-Younger Dryas period, DNA analysis reveals complex patterns of migration and mixing. They occurred as climate conditions improved and sea levels stabilized. These population movements weren't random wanderings of primitive hunter-gatherers. They represent organized relocations of people, carrying specific knowledge and skills to new territories. The genetic signatures of these migrations appear in modern populations as ghost lineages, traces of ancient groups that contributed to later civilizations, but have no clear archaeological correlates. These genetic ghosts suggest significant population movements occurred during the immediate post-Younger Dryas period, movements that could have spread preserved knowledge across vast distances. Genetic echoes. One particularly intriguing genetic signature appears in the DNA of early farming populations across Eurasia and Africa. These groups show evidence of admixture from unknown populations. They don't match any surviving hunter-gatherer groups from the same time periods. The genetic contributions appear suddenly in the record, suggesting that organized groups with different backgrounds integrated with local populations. During the agricultural transition, these mysterious genetic contributors might represent the survivors we've been discussing, people who maintained different lifestyles and knowledge systems through the Younger Dryas period, and emerged to share their expertise as conditions improved. Their genetic signatures would have been preserved in the populations they taught and influenced, creating the ghost lineages that puzzle modern researchers. The cultural implications of such genetic mixing extend far beyond simple population movements. When groups with advanced knowledge integrate with local populations, they don't just contribute genes, they contribute ideas, techniques, languages, and entire knowledge systems. All can transform the receiving cultures. This cultural transfer might explain the sudden appearance of sophisticated technologies and concepts in archaeological sites around the world: advanced metallurgy, complex astronomical knowledge, sophisticated architectural techniques, elaborate artistic traditions. All appear suddenly in the post-Younger Dryas record, often without clear developmental sequences in the cultures that display them. The timing of these appearances correlates closely with the genetic evidence of population mixing, suggesting that knowledge transfer accompanied genetic integration. The survivors weren't just preserving their own cultural traditions, they were actively teaching and sharing their knowledge with the hunter-gatherer populations they encountered as they emerged from their refugia. This sharing process might have been formalized through institutional structures designed to preserve and transmit knowledge across generations. The mystery schools of ancient Egypt, the astronomical colleges of Mesopotamia, the Celtic Druidic orders, and similar institutions in other cultures all served similar functions as repositories of recovered knowledge and training centers for its continued application. These mystery schools operated on principles of compartmentalized knowledge and redundant preservation, principles that seem almost modern in their sophistication. Different levels of initiation provided access to different categories of information, ensuring that the most crucial knowledge was protected from casual disclosure, while also preventing its complete loss if lower levels of the organization were compromised. Multiple schools in different regions maintained copies of the same essential information, creating backup systems that could restore lost knowledge if individual institutions were destroyed. The influence of these mystery schools extended far beyond their immediate membership. To shape the development of the civilizations that hosted them, the technical knowledge they preserved provided the foundation for architectural achievements, agricultural innovations, technological developments. All transformed human society. The astronomical knowledge they maintained enabled the development of accurate calendars, navigation systems, timing mechanisms, all supported complex social organization. Perhaps most importantly, the mystery schools served as bridges, connecting the pre-catastrophe past with the post-catastrophe future. They carried forward fragments of the lost world, while adapting them to the conditions and needs of the emerging one. Through their efforts, knowledge that might have died with the original civilization was preserved, transmitted, and eventually implemented. In new cultural contexts, the success of this knowledge preservation system is evident in the remarkable achievements of post-Younger Dryas civilizations. Within a few thousand years of climatic stabilization, human societies developed complex urban centers, sophisticated agricultural systems, monumental architecture, advanced metallurgy, elaborate artistic traditions. This rapid development wasn't the result of independent invention by primitive peoples, but the systematic recovery and implementation of knowledge, preserved through the catastrophic period, by dedicated institutions and their carefully trained practitioners. Yet, even as these achievements accumulated, the memory of catastrophe continued to influence human consciousness in ways that shaped cultural development for millennia. The flood myths, creation stories, apocalyptic traditions, they appear in virtually every human culture. They weren't just religious allegories, but encoded historical memories. They served as warnings about the fragility of civilization and the importance of preparation for future disasters. These mythological warning systems functioned as cultural immune responses, maintaining awareness of cosmic threats. Even when direct memory of the original catastrophe had faded, they ensured that future generations would retain at least some understanding of humanity's vulnerability to celestial events, while also preserving fragments of practical knowledge about survival and reconstruction techniques. The persistence of these warning systems across thousands of years and hundreds of cultures demonstrates the profound impact the Younger Dryas catastrophe had on human consciousness. Even today, long after the specific memories have been transformed into mythological narratives, we retain deep cultural anxieties about cosmic threats, global catastrophes, the possibility that our achievements might be swept away by forces beyond our control. These anxieties aren't irrational fears, but inherited wisdom, genetic and cultural memories. They remind us of truths our ancestors learned through terrible experience. The sky can burn, civilizations can fall, knowledge can be lost, but they also learned that humans can survive, rebuild and recover, even from cosmic catastrophe, if they maintain the wisdom to preserve what matters most, and the determination to begin again when everything seems lost. As you drift deeper into this ancient mystery, consider the profound resilience demonstrated by our ancestors. They faced the ultimate test of human adaptability and emerged victorious. They witnessed the destruction of their world, preserved fragments of their knowledge through over a millennium of harsh conditions, and then systematically rebuilt civilization to heights that in some ways surpassed what had been lost. Their achievement stands as a testament to the power of human consciousness to transcend even cosmic disaster, to the effectiveness of knowledge preservation systems designed by people who understood the true value of information, and to the unbreakable human spirit, a spirit that refuses to accept defeat, even when faced with the collapse of everything familiar and secure. The monuments they left behind continue to whisper their secrets to those willing to listen, revealing layer after layer of encoded information about the past, while also serving as warnings and guidelines for the future. In their precise alignments, mathematical relationships, and astronomical observations, we find not just impressive ancient achievements, but practical lessons about survival, reconstruction, and the preservation of knowledge through periods of chaos and disruption. The story of the Younger Dryas reset isn't just ancient history, it's a blueprint for human resilience, a demonstration that even the most devastating catastrophes cannot destroy the essential human capacity to learn, remember, adapt, and ultimately prevail. In the darkness of sleep, as consciousness fades and the rational mind releases its grip on linear time, perhaps we can still hear the echoes of that ancient wisdom, calling across the millennia, reminding us who we are and what we're capable of achieving. even in the face of impossible odds. The great work of reconstruction continues, each generation adding new knowledge to the foundation laid by the survivors, while also preparing for challenges yet to come. We are the inheritors of their triumph, the beneficiaries of their refusal to surrender, and the guardians of knowledge they deemed worth preserving. Through cosmic catastrophe, in our dreams and in our waking hours, their legacy lives on, a testament to the indomitable human spirit, a spirit that transforms even the greatest disasters into opportunities for renewal and growth. Beyond memory. The deeper we venture into this reconstructed world, the more we begin to understand that the survivors didn't just preserve knowledge, they transformed it. Picture yourself standing in the shadow of the Great Pyramid at dawn, watching as the first rays of sunlight strike its precisely angled faces. The mathematics encoded in its proportions speak of understanding that extends far beyond what any Bronze Age civilization should have possessed. Yet here it stands, a testament to knowledge that seems to have emerged from nowhere, fully formed, impossibly sophisticated. But perhaps it didn't emerge from nowhere at all. Perhaps what we're witnessing is the flowering of seeds planted long before, knowledge that had been carefully tended through the dark centuries, and finally given the conditions it needed to grow into something even greater than what had come before. The survivors weren't just rebuilding their lost world, they were improving upon it, learning from the catastrophe that had nearly destroyed them, and creating something more resilient, more enduring, more capable of surviving whatever the cosmos might throw at humanity next. This process of improvement through reconstruction explains one of the most puzzling aspects of post-Younger Dryas civilizations. They didn't just recover the achievements of the past, they surpassed them. The architectural techniques that emerge in the millennia following the climate stabilization are more sophisticated than anything we can definitively attribute to pre-catastrophe cultures. The astronomical knowledge encoded in monuments like Stonehenge and the Giza complex exceeds what would have been necessary for simple agricultural societies, suggesting access to observational data and mathematical frameworks developed over far longer periods than conventional timelines allow. Consider the implications of this improvement pattern. The survivors who carried knowledge through the catastrophic period weren't passive preservers of ancient wisdom. They were active innovators, taking the fragments they had maintained and weaving them into new systems adapted to post-catastrophe conditions. They learned from their near-extinction experience, developing more robust preservation methods, more redundant information storage systems, more effective techniques for transmitting crucial knowledge across generations and geographical distances. This innovation through preservation explains why post-Younger Dryas achievements often seem to contain knowledge that exceeds what their supposed inventors could have developed independently. The megalithic builders weren't starting from scratch with crude stone-moving techniques. They were implementing refined systems that had been tested, improved, and perfected through thousands of years of development. The astronomical observers weren't beginning with basic sky watching. They were working from mathematical frameworks and observational databases that represented millennia of accumulated knowledge. The art of teaching. The refinement process becomes even more remarkable when we consider the conditions under which it occurred. The survivors who carried this knowledge forward weren't working in comfortable academic settings. With abundant resources and leisure time for experimentation, they were operating in harsh post-catastrophe conditions, dealing with unstable climate, disrupted ecosystems, scattered populations. Yet somehow they managed not just to preserve their inherited knowledge, but to improve upon it, creating systems more sophisticated than what had existed before the disaster. This achievement required more than just technical knowledge. It demanded profound understanding of human psychology, social organization, and the mechanisms by which complex information can be transmitted across cultural boundaries. The survivors had to become master teachers, capable of sharing advanced concepts with hunter-gatherer populations who had no prior exposure to such sophisticated ideas. They had to develop educational methods that could transform nomadic bands into organized construction crews, agricultural communities, astronomical observers. The success of this educational enterprise is evident in the rapid transformation of human society, a transformation that followed the climate stabilization. Within a few centuries of the Younger Dryas ending, we see the emergence of complex settlements, sophisticated farming systems, monumental construction projects across multiple continents. This wasn't gradual evolution, but systematic implementation of educational programs. Programs designed to rebuild civilization according to improved specifications. The educational methods developed by the survivors might explain another persistent mystery in ancient studies: the appearance of nearly identical symbols, measurement systems, and construction techniques in cultures separated by vast distances and supposedly having no contact with each other. If the survivors were working from standardized educational curricula based on pre-catastrophe knowledge systems, then the similarities between distant cultures become evidence, not of independent invention, but of shared instruction from common sources. These standardized systems appear in the mathematical relationships encoded in monuments around the world, the astronomical alignments that track identical celestial phenomena across different continents, and the construction techniques that solve identical engineering problems. Using nearly identical methods, the consistency suggests that the knowledge being transmitted wasn't just technical information, but complete educational frameworks, designed to produce specific results, regardless of local conditions or cultural variations. The development of such sophisticated educational systems required understanding of learning processes that wouldn't be formally studied until the modern era. The survivors had to understand how complex information could be broken down into manageable components, how different types of learners could be accommodated within the same instructional framework, and how knowledge could be adapted to different cultural contexts without losing its essential accuracy. Verifying the unseen. They also had to solve the problem of knowledge verification, ensuring that the information being transmitted remained accurate across multiple generations of teachers and students. This challenge was particularly acute, given that much of the knowledge involved mathematical and astronomical concepts that couldn't be easily verified through everyday experience. How do you confirm that your calculations of planetary cycles are correct when the cycles take centuries to complete? How do you verify that your mathematical constants are accurate when the applications involve measurements beyond the capabilities of available tools? The solution appears to have involved the development of cross-referencing systems that allowed different aspects of the knowledge base to confirm each other's accuracy. Mathematical constants could be verified through their appearance in multiple astronomical calculations. Astronomical observations could be confirmed through their correlation with architectural alignments. Construction techniques could be tested through their incorporation into monuments designed to last for millennia. This cross-referencing approach created knowledge networks, where individual pieces of information were supported by multiple independent confirmations, making the entire system highly resistant to the kinds of gradual corruption that typically affect information transmitted across long time periods. The result was educational frameworks that could maintain their accuracy across thousands of years and hundreds of cultural transmissions. The sophistication of these preservation systems becomes apparent when we examine how consistently certain mathematical relationships appear in monuments built across different time periods and geographical locations. The golden ratio appears with identical precision in structures separated by thousands of miles and centuries of time. The value of pi is encoded with remarkable accuracy in monuments built by cultures that supposedly had no contact with each other. These consistencies aren't coincidences, but evidence of educational systems designed to maintain mathematical precision across vast spans of time and space. Consciousness engineering. But the survivors weren't just preserving mathematical and astronomical knowledge, they were also maintaining understanding of more subtle principles related to consciousness, perception, and the relationship between human awareness and natural phenomena. Many ancient monuments incorporate features that seem designed to induce specific psychological or physiological states in their users, suggesting sophisticated understanding of how environmental factors affect human consciousness. The acoustic properties of stone circles, for example, create resonance effects, effects that can induce altered states of consciousness in people participating in ceremonies within them. The precise alignments of passage tombs with celestial events create dramatic lighting effects, effects that would have profound psychological impact on observers. The mathematical proportions incorporated into sacred architecture correspond to ratios that modern research has shown to have calming or energizing effects on human perception. These consciousness-affecting features weren't accidental byproducts of construction techniques designed for other purposes. They represent deliberate applications of knowledge about the relationship between environmental conditions and human awareness, knowledge that suggests the pre-catastrophe civilizations had developed sophisticated understanding of psychology, neurology, and the mechanisms by which external stimuli affect internal experience. The preservation and application of this consciousness-related knowledge points to educational systems that included training in what we might now call applied psychology or environmental therapy. The survivors weren't just teaching their students how to build impressive structures or track celestial movements. They were instructing them in techniques for creating environments that could enhance learning, facilitate memory formation, and induce states of consciousness conducive to the transmission of complex information. This psychological dimension of the knowledge preservation system helps explain how such sophisticated concepts could be successfully transmitted to populations that had no prior exposure to advanced mathematical or astronomical ideas. The educational environments created by the survivors weren't just classrooms, but carefully designed spaces that optimized the conditions for learning and memory formation. The monuments themselves served as teaching aids, their proportions and alignments creating psychological states that enhance the absorption and retention of complex information. The integration of consciousness research with technical knowledge created educational systems that were remarkably effective at producing rapid transformation in student populations. Hunter-gatherer groups exposed to these teaching methods could apparently be transformed into skilled builders, accurate astronomical observers, competent agricultural planners, all within relatively short time periods. The speed of this transformation suggests educational techniques far more sophisticated than anything recognized in conventional historical accounts. But perhaps most remarkably, the survivors managed to embed self-improving mechanisms into their knowledge preservation systems. The educational frameworks they created weren't static repositories of ancient information, but dynamic systems capable of incorporating new discoveries while maintaining the accuracy of established principles. This adaptability allowed the recovered knowledge to continue evolving and improving, even as it was being transmitted across cultures and generations. Evidence for these self-improving systems appears in the progressive sophistication of monuments built over time within the same cultural traditions. Later structures often display refinements and improvements over earlier ones, suggesting that the knowledge base was continuing to develop. Rather than simply being copied from fixed templates, the builders were learning from their experience, incorporating new techniques and discoveries, while maintaining the essential accuracy of their foundational principles. This combination of preservation and innovation created knowledge systems that were both stable and adaptive, capable of maintaining crucial information across millennia, while also allowing for continued development and refinement. The result was civilizations that could build upon their inherited knowledge, rather than simply repeating it, creating achievements that often surpassed what had existed before the catastrophe. The success of these adaptive preservation systems is evident in the continued development of human civilization throughout the post-Younger Dryas period. Each generation built upon the achievements of its predecessors, creating increasingly sophisticated technologies, more complex social organizations, and deeper understanding of natural phenomena. The knowledge recovery that began immediately after the climate stabilization continued for thousands of years, producing civilizations whose achievements still inspire wonder and admiration today. The unending legacy. Yet, even as these civilizations flourished and expanded, they never forgot the lessons learned from the catastrophe that had nearly destroyed their predecessors. The consciousness of cosmic vulnerability remained embedded in their cultures, expressed through flood myths, apocalyptic traditions, elaborate preparations for future disasters. They built their achievements to last, not just for their own lifetimes, but for geological ages, creating monuments designed to preserve essential knowledge through any conceivable catastrophe. This long-term perspective influenced every aspect of post-Younger Dryas civilizations, from their architectural choices, to their social institutions, to their spiritual beliefs. They understood that human achievements were fragile in the face of cosmic forces, but they also understood that knowledge and wisdom could survive even the most devastating disasters if they were properly preserved and transmitted. The monuments they created serve as testaments to this understanding, encoding essential information in forms designed to outlast any conceivable catastrophe, while also providing the foundations for rebuilding civilization, if such reconstruction should ever become necessary again. In their mathematical relationships, astronomical alignments, and construction techniques, we find not just impressive ancient achievements, but practical blueprints for survival and reconstruction. As the night deepens around us and consciousness begins its natural drift towards sleep, we can sense the presence of that ancient wisdom, still embedded in the world around us. The stones remember what flesh forgets, holding their secrets in precise angles and calculated proportions, waiting for minds capable of reading their encoded messages. In the alignment of shadows at dawn, in the mathematical relationships that govern natural forms, in the deep rhythms that connect earth and sky, the knowledge of the survivors continues to whisper its lessons to those willing to listen. The great work of reconstruction that began over 12,000 years ago continues still, each generation adding new understanding to the foundation laid by those who refuse to let cosmic catastrophe destroy human wisdom. We are the inheritors of their triumph, the beneficiaries of their determination, and the guardians of knowledge they deemed worth preserving through the ultimate test of survival. In our dreams and in our waking hours, in the monuments that still stand, and in the discoveries yet to be made, their legacy endures as proof that human consciousness can transcend even cosmic disaster, that knowledge carefully preserved can outlast any catastrophe, and that the essential human spirit of inquiry, innovation, and hope remains as indestructible as the mathematical constants encoded in stone, by hands that knew the true value of what they were preserving, for futures they would never see, but refused to abandon to ignorance or despair. The rhythm of ancient wisdom continues its patient pulse through time, connecting us to ancestors who faced the unthinkable and emerged victorious, reminding us that we too carry within our consciousness the seeds of knowledge, seeds that can survive any catastrophe and bloom again in any conditions, given the determination to remember what matters most and the courage to begin again, when everything familiar has been swept away by forces beyond our control, but not beyond our capacity to understand, adapt to, and ultimately transcend. And yet, as we trace these currents of ancient knowledge flowing through time, we encounter something even more extraordinary than individual achievements preserved in stone and star. We find evidence of a living memory, a consciousness that transcended the boundaries between individual minds and became something collective, something that could survive the death of entire civilizations and be reborn in new forms across vast expanses of time and geography. This collective memory manifests in ways that challenge our understanding of how information can be stored and transmitted across generations. Indigenous cultures around the world speak of ancestral knowledge, knowledge that exists not in books or monuments, but in the land itself, encoded in the patterns of rivers and mountains, preserved in the behavior of animals and the cycles of plants. They describe a form of knowing that doesn't depend on human teachers, but emerges from deep communion with natural systems, systems that have remained unchanged since the time before the catastrophe. Our ancestral memory. Modern science is beginning to recognize that this indigenous understanding might be more literal than metaphorical. Recent research into epigenetics reveals that traumatic experiences can alter gene expression in ways that affect not just the individuals who experience them, but their descendants for multiple generations. The genetic memory of catastrophe might be embedded in our very DNA, influencing our behaviors and perceptions in ways we're only beginning to understand. If the Younger Dryas impact created such profound trauma that it altered human genetic expression, then every person alive today carries within their cells the molecular memory of that cosmic catastrophe. We are all descendants of survivors, inheritors not just of their knowledge, but of their cellular memories, their genetic adaptations, and their deep awareness of humanity's vulnerability to forces beyond our control. This genetic inheritance might explain the persistent human fascination with cosmic threats, apocalyptic scenarios, stories of lost civilizations. These aren't just cultural preferences or psychological archetypes, but genetic memories, expressing themselves through our collective unconscious. The anxiety we feel when contemplating asteroid impacts or climate catastrophes isn't irrational fear, but inherited wisdom, cellular knowledge that reminds us of truths our ancestors learned through terrible experience. But genetic memory isn't the only mechanism by which the knowledge of the survivors continues to influence human consciousness. The monuments they built weren't just repositories of mathematical and astronomical information, but generators of specific psychological states, states designed to activate dormant aspects of human awareness and reconnect modern minds with ancient understanding. The precise acoustic properties of megalithic structures create sound environments. Environments that can induce altered states of consciousness in people who spend time within them. The mathematical proportions incorporated into sacred architecture correspond to ratios that resonate with fundamental patterns in human brain activity. The astronomical alignments that bring celestial light into contact with carefully positioned stones create moments of transcendent beauty, moments that seem to awaken something deep within the human psyche. These consciousness-altering effects weren't accidental byproducts of construction techniques, but deliberate applications of knowledge about the relationship between environmental conditions and human awareness. The survivors understood that true knowledge couldn't be preserved simply by encoding it in symbols or structures. It had to be embedded in systems that could reactivate the states of consciousness necessary to understand and utilize that knowledge. The great temples and stone circles around the world might therefore be understood as consciousness laboratories designed to induce specific mental states that would allow users to access levels of awareness that had been common before the catastrophe, but were largely lost in the harsh conditions that followed. By creating environments that could temporarily restore these expanded states of consciousness, the monuments served as bridges between the limited awareness of post-catastrophe humanity and the broader understanding that had characterized pre-disaster civilizations. This interpretation transforms our understanding of ancient spirituality, from primitive superstition to sophisticated neurotechnology. The elaborate rituals that took place at megalithic sites weren't meaningless ceremonies, but practical techniques for accessing enhanced states of consciousness. The priests and shamans who conducted these rituals weren't religious fanatics, but trained technicians, specialists in the application of consciousness-altering technologies preserved from the lost world. The effectiveness of these techniques is evidenced by the remarkable achievements of the civilizations that employed them. Societies that incorporated consciousness-expanding practices into their cultural and educational systems consistently displayed capabilities that exceeded what conventional historical models would predict. They developed mathematical concepts before they supposedly had the cultural foundations to support such abstract thinking. They created astronomical systems that required observational capabilities beyond what their available tools should have allowed. They coordinated massive construction projects without the organizational technologies that modern analysis suggests would have been necessary. Collective intelligence. These achievements become comprehensible when we recognize that the consciousness expansion techniques preserved by the survivors allowed access to levels of mental functioning, levels that are largely dormant in modern humans. The enhanced pattern recognition, expanded memory capacity, increased computational ability, all can be achieved through specific consciousness states. They would have provided the cognitive resources necessary for the remarkable achievements we observe in ancient civilizations. But the consciousness technologies weren't just tools for individual enhancement. They were systems for creating collective intelligence, methods for linking multiple minds into coordinated networks, Networks that could process information and solve problems at levels far beyond what any individual could achieve alone. The elaborate group ceremonies that took place at megalithic sites weren't just spiritual gatherings, but practical applications of collective consciousness technologies. These group consciousness techniques might explain one of the most persistent mysteries in ancient archaeology: how relatively small populations managed to coordinate the construction of massive monuments that would challenge modern engineering capabilities. The conventional explanations require us to believe that thousands of workers could be organized, using only primitive communication methods and basic management techniques. But if the builders had access to consciousness technologies that allowed for direct mind-to-mind coordination, then the organizational challenges become much more manageable. The evidence for such collective consciousness applications appears in the remarkable precision with which ancient construction projects were executed. The fit between massive stone blocks at sites like Sacsayhuaman and Puma Punku is so precise that it suggests levels of coordination and timing, levels that would be difficult to achieve even with modern communication technologies. The builders seem to work as if they shared a common mind, anticipating each other's actions and coordinating their efforts with an efficiency that borders on the supernatural. This collective coordination extended beyond individual construction sites to encompass entire networks of monuments, spread across vast geographical areas. The geometric relationships between megalithic sites separated by hundreds or thousands of miles suggest planning and implementation capabilities that required communication and coordination methods far more sophisticated than anything recognized in conventional historical accounts. If the survivors had preserved consciousness technologies that allowed for long-distance mental communication, then the coordination of global construction projects becomes not just possible but inevitable. Groups working in different parts of the world could have maintained constant contact, sharing information and coordinating their efforts in real time, despite the vast distances that separated them physically. This possibility is supported by indigenous traditions from around the world, traditions that describe methods for long-distance communication through altered states of consciousness. Aboriginal Australians speak of dreamtime connections that allow information to be shared across continental distances. Native American traditions describe vision quests and shamanic journeys that provide access to knowledge from distant locations. Tibetan Buddhism includes practices designed to achieve consciousness states that transcend normal limitations of time and space. These traditions might preserve fragments of the communication technologies that allowed the post-Younger Dryas reconstruction to proceed with such remarkable coordination and efficiency. If so, then the consciousness expansion techniques weren't just methods for individual enhancement, but components of a global communication network. A network that connected human minds across vast distances and allowed for unprecedented levels of coordination and cooperation. The implications of such communication capabilities extend far beyond construction coordination to encompass the preservation and transmission of knowledge itself. If information could be shared directly from mind to mind, then the challenges of maintaining accuracy across generations and cultural boundaries would be greatly reduced. Complex mathematical concepts, detailed astronomical observations, sophisticated technical procedures, all could be transmitted with perfect fidelity, ensuring that crucial knowledge remained unchanged, regardless of how many times it was passed from teacher to student. This direct transmission method might explain the remarkable consistency of certain knowledge systems across ancient civilizations. Mathematical constants appear with identical precision in monuments built by cultures that supposedly had no contact with each other. Astronomical observations remain accurate across centuries of cultural transmission. Construction techniques maintain their sophistication, despite being applied in radically different geographical and cultural contexts. The preservation of such precision across time and distance suggests transmission methods far more reliable than normal human communication. If the survivors had developed technologies for direct mind-to-mind knowledge transfer, then the consistency of ancient achievements becomes not just explainable but inevitable. The living wisdom. But perhaps the most remarkable aspect of these consciousness technologies was their ability to transcend the limitations of individual human lifespans. If knowledge could be stored in collective consciousness fields, fields that existed independently of individual minds, then the death of specific teachers wouldn't result in the loss of crucial information. The knowledge would continue to exist in the collective field, accessible to future students who learned the techniques necessary to connect with it. This possibility transforms our understanding of how ancient knowledge was preserved through the catastrophic period and beyond. Instead of relying solely on individual survivors to maintain crucial information through their personal memories, the preservation system might have included methods for storing knowledge in collective consciousness fields that could survive even the death of all the individuals who had contributed to them. These collective knowledge fields would explain how complex information systems could emerge suddenly in the post-Younger Dryas world. Without clear developmental sequences, the knowledge wasn't being invented from scratch, but was being accessed from collective storage systems that had been maintained throughout the catastrophic period. Different groups of survivors in different parts of the world could have accessed the same knowledge fields, producing the consistent results we observe across ancient civilizations. The accessing of collective knowledge fields might also explain the sudden appearance of individuals with remarkable abilities. In ancient historical accounts, the great architects, astronomers, and mathematicians, they seem to emerge from nowhere with fully developed skills. They might have been people who had learned to access the collective knowledge systems more effectively than their contemporaries. These exceptional individuals wouldn't have been isolated geniuses, developing new ideas through individual inspiration, but would have been specialists in consciousness technologies, trained to serve as interfaces between the collective knowledge fields and the ordinary human communities that needed access to that information. Their role would have been similar to that of modern computer technicians, translating complex digital information into forms that non-specialists could understand and apply. The training of such interface specialists would have been one of the most crucial functions of the mystery schools and similar institutions that emerged in post-Younger Dryas civilizations. These organizations wouldn't just have been preserving ancient knowledge, but would have been maintaining the consciousness technologies necessary to access collective knowledge fields, and training individuals to serve as bridges between those fields and ordinary human society. The effectiveness of these interface systems is evidenced by the rapid development and widespread distribution of sophisticated knowledge throughout the ancient world. Complex mathematical concepts, detailed astronomical observations, advanced technical procedures, all spread across vast distances and cultural boundaries, with remarkable speed and accuracy, suggesting communication and educational systems far more efficient than anything conventional history recognizes. As we drift deeper into the realm where consciousness touches the edges of collective memory, we begin to sense the presence of something vast and ancient, something that continues to influence human awareness in ways we're only beginning to understand. The knowledge preserved by the survivors wasn't just information stored in books and monuments, but living wisdom, embedded in consciousness fields that remain accessible to those who learn the techniques necessary to connect with them. In the quiet moments when rational thought relaxes its grip and intuitive awareness emerges, we might still catch glimpses of that ancient knowing, fragments of understanding, fragments that seem to come from somewhere beyond individual memory, yet feel more familiar than our own thoughts. These aren't just moments of expanded awareness or paradoxical experiences, but practical connections to knowledge systems that were designed to outlast any conceivable catastrophe and remain available to future generations who might need their guidance. The great work of reconstruction that began over 12,000 years ago continues. In every moment of expanded consciousness, every flash of intuitive insight, every recognition of patterns that connect individual experience to universal principles, we are all participants in this ancient project, inheritors of consciousness technologies that can transform individual awareness into collective wisdom and connect finite human minds to infinite reservoirs of knowledge that transcends the limitations of time, space, and individual existence. In the deepening silence of night, as the boundaries between waking and sleeping consciousness begin to blur, we can sense the patient presence of that collective wisdom, waiting to be rediscovered, not as something external to ourselves, but as the deepest truth of what we are and what we're capable of becoming. when we remember how to access the unlimited potential that lies dormant within every human mind, preserved across eons of time, like seeds waiting for the right conditions to germinate and bloom once again into the fullness of what our ancestors knew we could become. The whisper of ancient knowledge continues its eternal song, calling across the millennia to remind us that we are more than we remember, capable of more than we imagine, and connected to sources of wisdom that can guide us through any darkness, toward the light of understanding that shines beyond all catastrophe, all forgetting, and all the apparent limitations that separate us from the infinite potential that is our true inheritance, from the survivors who refuse to let the light of human consciousness be extinguished by cosmic fire or earthly flood, preserving it instead in forms that could outlast any disaster and illuminate any future that might need its guidance. The threads of this ancient tapestry begin to weave together as we approach the present moment, where the buried memories of our species stir beneath the surface of modern consciousness, like seeds that have waited through geological ages for the right conditions to sprout. In our own time, as technology allows us to peer deeper into the past than ever before, we're discovering that the story of the Younger Dryas reset isn't just ancient history, but a living presence. A presence that continues to shape human experience in ways both subtle and profound. Consider how often we find ourselves drawn to stories of lost civilizations, fallen empires, forgotten golden ages. This isn't mere entertainment or escapism, but something deeper. A recognition that resonates in the cellular memory of our species. When we watch films about ancient mysteries, or read books about vanished cultures, we're not just consuming fiction, but reconnecting with fragments of our own deepest history, memories that live in our genes and whisper through our dreams. The fascination with apocalyptic scenarios that permeates modern culture might similarly reflect genetic memories. Memories of the cosmic catastrophe that reset our world 12 millennia ago. The movies about asteroid impacts, the books about global catastrophes, the persistent anxiety about climate change and civilizational collapse. All these might be expressions of inherited trauma, cellular warnings passed down from ancestors who witnessed the sky burn and the world flood, and wanted their descendants to remember that such things were possible. But alongside these warnings, we also carry within us the genetic memory of survival, reconstruction, and ultimate triumph over seemingly impossible odds. The human drive to preserve knowledge, to build monuments that will outlast our individual lives, to encode important information in multiple formats and locations. All these behaviors might reflect inherited wisdom from survivors who understood that preparation and redundancy were the keys to outlasting catastrophe. This inherited wisdom expresses itself in our modern obsession with backing up digital information, preserving cultural artifacts, and maintaining seed banks and genetic repositories. We build libraries and museums with the same instinctive drive that led our ancestors to encode knowledge in stone circles and megalithic temples. We create redundant communication networks and distributed storage systems with the same understanding that motivated the builders of the global monument network, a network that emerged after the Younger Dryas. The consciousness technologies preserved by the survivors might also be experiencing a renaissance in our current era, though we often don't recognize them for what they are. The meditation practices that have become increasingly popular in recent decades, the binaural beat technologies that can induce altered states of consciousness, the virtual reality systems that create immersive environments designed to affect human awareness. All these might be modern rediscoveries of ancient techniques for expanding consciousness and accessing enhanced cognitive capabilities. The recent scientific interest in psychedelic compounds and their therapeutic applications might similarly represent a reconnection with consciousness expansion methods that were common before the catastrophe, but largely lost during the harsh conditions that followed. The profound insights and enhanced pattern recognition that these substances can facilitate might provide glimpses of the expanded awareness that was normal for pre-Younger Dryas humanity. Modern neuroscience is beginning to confirm what the survivors encoded in their monuments and preservation systems, that human consciousness is far more malleable and expandable than we typically realize. The brain's capacity for neuroplasticity its ability to form new connections and develop enhanced capabilities throughout life, suggests that the consciousness technologies of the ancient world might have been based on accurate understanding of human neurological potential, rather than primitive superstition. The emerging field of epigenetics is revealing that our genes carry memories of ancestral experiences in ways that directly affect our present-day physiology and behavior. If the Younger Dryas catastrophe was traumatic enough to alter human genetic expression, then every person alive today carries within their cells not just the memory of that event, but also the adaptive responses that allowed our ancestors to survive and rebuild. These genetic memories might explain why certain mathematical relationships feel inherently satisfying to human perception, why specific acoustic frequencies can induce profound emotional responses, and why particular geometric proportions appear repeatedly in art and architecture. Across all cultures and time periods, we're not just creating beauty according to arbitrary aesthetic preferences, but expressing genetic memories of the consciousness technologies that were encoded in ancient monuments. The global communication networks that connect our modern world might represent an unconscious attempt to rebuild the collective consciousness systems that allowed the post-Younger Dryas civilizations to coordinate their reconstruction efforts across vast distances. The internet, with its capacity for instantaneous information sharing and collective problem solving, might be a technological approximation of the direct mind-to-mind communication methods that the survivors developed to maintain contact across their scattered communities. The current explosion in artificial intelligence research and development might similarly reflect an inherited drive, a drive to recreate the enhanced cognitive capabilities that were available to ancient consciousness technicians, the algorithms that can recognize patterns in vast datasets, the machine learning systems that can solve problems beyond human individual capacity, and the neural networks that can process information in ways that mirror collective intelligence. All these might be technological attempts to rebuild capabilities that were once accessible through biological consciousness expansion techniques. But perhaps most significantly, we're living through what might be another period of cosmic vulnerability, similar to the one that precipitated the Younger Dryas catastrophe. Modern astronomy identified numerous asteroid and comet threats that could potentially impact Earth with devastating consequences. Climate scientists warn of rapid environmental changes that could destabilize global civilization. The possibility of solar flares, supervolcanic eruptions, and other natural catastrophes continues to concern researchers who study existential risks to human survival. The consciousness that drives modern efforts to identify and prepare for these threats might reflect genetic wisdom inherited from ancestors who learned through terrible experience that cosmic catastrophes are not just theoretical possibilities, but recurring realities that require constant vigilance and preparation. The space agencies that monitor near-Earth objects, the climate research programs that track environmental changes, and the disaster preparedness initiatives that attempt to coordinate global responses to potential catastrophes. All these might be modern expressions of the early warning systems that the survivors tried to rebuild after the Younger Dryas impact. The growing interest in establishing human settlements on other planets might similarly reflect inherited understanding that civilizational survival requires spreading human presence across multiple locations to prevent total extinction from single-point catastrophes. The genetic memory of watching entire coastal civilizations disappear beneath rising seas might drive our current efforts to ensure that human consciousness and knowledge can survive, even if Earth itself becomes temporarily uninhabitable. But the most profound legacy of the Younger Dryas survivors might be the understanding that human consciousness itself is the ultimate survival technology. Knowledge can be preserved in books and databases, but wisdom must be maintained in living minds. Technologies can be rebuilt from blueprints and specifications, but the understanding necessary to create and apply those technologies must be carried forward by people who comprehend not just the technical details, but the deeper principles that make the technologies effective. The survivors who rebuilt civilization after the cosmic catastrophe weren't just preserving information, but maintaining consciousness, keeping alive the capacity for human awareness to expand beyond its normal limitations and connect with sources of knowledge that transcend individual experience. Their greatest achievement wasn't the monuments they built or the knowledge they preserved, but the consciousness technologies they developed to ensure that human potential could be maintained and transmitted across any conceivable disruption. As we reach the edge of this ancient mystery, drifting in the space between sleeping and waking, we find ourselves inheritors of the greatest story never told. The Younger Dryas wasn't just a climate event or cosmic accident. It was humanity's first reset. The moment when fire fell from the sky, and everything our ancestors had built vanished, beneath ice and flood. Yet from that catastrophe emerged something even more remarkable than what was lost. The survivors who carried fragments of knowledge through 12 centuries of darkness didn't just rebuild civilization, they transformed it, encoding their hard-won wisdom into stone and star, myth and monument. Today, as we face our own cosmic vulnerabilities and civilizational challenges, their whispered warnings and encoded blueprints for survival continue to guide us. We are all descendants of those who refuse to let the light of human consciousness be extinguished, and their greatest lesson echoes still. Knowledge can survive any catastrophe if we have the wisdom to preserve it and the courage to begin again when everything seems lost. This narrative has only scratched the surface of the Younger Dryas mystery. There are countless more layers to peel back, more forgotten truths waiting in the esoteric archives of our past. If this deep dive into lost civilizations and cosmic resets ignites your curiosity, you'll find an entire playlist of similar forbidden histories and unexplained phenomena. The link is in the pinned comment below. What do you think? Did an ancient civilization truly face a cosmic reset? Or is this all an elaborate coincidence? Share your theories in the comments. Your perspective matters. Your curiosity fuels this journey.